Okay, so this is a introduction to looking at binomial distributions, and today we won't be on the whiteboard, we'll be looking at a PowerPoint presentation. So this video will go through the basics, and hopefully you'll be able to understand a bit more about what a binomial distribution is, and a few of the fundamental calculations associated with this. So first off, key features of a binomial distribution. There are generally only two outcomes. We generally refer to this as being a success or a failure. There are generally a fixed number of trials, which are generally given by n, and trials are independent of one another. Each trial has the same probability of success, so hence it is with replacement, and order does not matter when we're generally looking at the probabilities. Two possible outcomes, as I said before, are success and failure based. So this will become more apparent as we go through the conceptual side of binomial distributions, but for now let's get into some of the mathematical concepts. Let me first start off with Pascal's triangle. I've got a few little properties of Pascal's triangle up here on the board. I won't dwell over a lot of them, but the main one I want to point out is the fact that it's symmetrical, which you'll gain an appreciation of later in the unit on binomial distributions, and also the fact that we use binomial distributions to some degree with Pascal's triangle. It is involved in the calculations that we do. So let's have a look at the idea of possible outcomes. Now, on the last slide, you would have noticed that the Pascal's triangle, again, if we had a number, so if I just get my mouse here, if we have 1 and 1 here, 1 plus 1 is going to make 2, the number underneath. That's how we actually get the triangle. But when we have the possible outcomes, we have success, which would be down here, and this would be the actual column 0 along here. So this would be the column representing 0 success. So that's how we sort of label it when we think about it in a binomial sense. And this will become more apparent again when I explain a bit more about Pascal's triangle. But again, think of this as success down there and failure down there. And this is 0 success, and we have 1 success, and we have 2 success, 3 success, and such forth across the actual Pascal's triangle. So again, let's move on and have a look at what this actually means. But let's consider a single coin toss. So we're looking at trial 1. So we label each row. Again, we start with 0 as the first row, and then we have row 1. So with a single coin toss, a little hint with Pascal's triangle is that each row represents a trial. So we're going to be looking at row 1 there, which has the number 1 and 1. And again, we have our success and failure. Success is heads, and our failure is tails. So using Pascal's triangle, we have to have an idea of how many different ways there are to get heads off a single coin toss. So again, maybe I have an annotation tool here. Yep, that's good. So this is the row we're looking at. Hopefully I'm able to draw of it. Oops, maybe not. Okay, but I've given away the answer there. So the answer is technically 1. In fact, is technically 1 because we're looking at 1 success. So this is, as I said, getting 0 heads and then getting 1 heads would be in there. And off a single trial, the probability of getting 1 heads is that value there in the 1 heads column. So you either get heads or you don't get heads. That's the logic behind it. And the same is true for tails, as we're going to see in a moment. And again, it's why the first one in the row is getting tails is because we get 0 heads, and there's one possible outcome, in which case to get 0 heads we're of course going to have to get a tails off that coin toss. So each row, as I said before, is a trial, and a trial either has a success or a failure, so something we do want or something we don't. That should hopefully be quite obvious, because again this is quite a simple concept so far behind Pascal's triangle. So now something that probably would help, again answering a few of the next questions, although I'm going to go through the answers, would be to actually have Pascal's triangle in front of you. So with the knowledge that the sum of the numbers above it represents the value below, have a go at constructing the first 5 or 6 rows And again, number each row with the number that represents the trials, so you can easily pick out the rows. You can pause the video while you do this. Okay, so we look at the fifth row and the third number across, and that's where we include the 1 on the outside. What is the significance of this value? Well, when we think about it, if we're looking at the fifth row, so we've gone 5 rows down, and we're looking at the third number across, the first value across would be the chance of getting 0 successes from 5 trials, or the number of ways to get 0 successes from 5 trials, sorry. The first row would be the number of ways to get one success from 5 trials. And then the third number across, which is the value we're interested in, would of course be 2 successes from 5 trials. So that's how we're able to derive the significance of this value. So, yep, this is the number of ways to get 2 successes from 5 trials. Again, if you want to do an extension, treat heads as successes in a coin toss and determine the possible combinations to get this desired result. And again, order does not matter. So that's it just if you want to. You can pause the video and have a go at that, but it's up to you. That's just thinking about the actual combination of ways of getting 2 successes from 5 trials. So we've now got a Pascal's triangle drawn, hopefully when you pause the video before and you understand what a trial is and the basic idea of success and failure. So now let's have a look at multiple trials. So let's look at row 2 of the Pascal triangle, which is of course the third row down, because it represents 2 trials. So let's first start with this probability tree here, and we see we've got a first toss, and it's 50-50 whether we get heads and tails. And on the second toss, if we got heads on the first time, it's then another 50-50 for getting heads and tails. And then on the actual second toss here, where we got tails the first time round, again it's 50-50 for heads and tails as well. But as you can see from this, we have one actual probability where we get 2 heads, and then we get 2 probabilities where we get 1 of each. Again, order doesn't really matter, there's 2 different ways of actually doing it though. And then the probability on the toss here is that we actually get 1 way where we have 2 lots of heads. So the question asks how many possible ways are there. We've sort of gone through that again with 2 heads, 2 tails, and getting 1 of each. But let's again tie this into a triangle. We have 1 way of getting 0 successes, which would be all tails. Again, we get 2 tails there. Second box represents getting 1 of each. And again, there's 2 ways to do that. And then the third box again represents getting heads twice, because it's, look here, we've got 0 successes, 1 successes, 2 successes, 2 successes out of 2 trials means heads and heads, and again, it's only 1 way to do this. And you can note that the actual pyramid is symmetrical here. We have 1 and 3, then we have 3 and 1, and we've got 1, 4, and then we have 6 in the middle, and then, as you can see, it's symmetrical because, essentially, with these symmetrical probabilities, where it's a 50-50 chance, again, you have the number of ways in order to do it, and even with things that don't necessarily have a 50-50 chance, there are a set number of ways over a given trial, so that we can actually get a success or failure, and again, they sort of link up with the symmetry there. So again, with this extension, try having free coin tosses and evaluate the possible number of outcomes for each of the 3 questions there, where we had all heads, at least 1 of each or 2 of each. And again, just write them down if you're interested. Again, you can pause the video to do this, or you can just choose to move on. So now let's have a look at some calculator functions, so NCR. And with NCR, it's an easy way to find the number of outcomes for a particular success rate. And it can be done using a graphics calculator, which is good. So on the T84, you want to go into the Math menu, go across to Probability by pressing the right arrow key a couple of times, and then select the third option. As you can see, it is shown on the screens here, and it shows you the number of ways one can actually have from 2 trials, 2 successes, again down here, so it's 2 NCR2, and as you can see it's one way.